All right, everyone, we're back with lesson 8.2 on surface area. So surface area of a solid is the sum of the area of all its faces. You can use a two-dimensional 2D representation of a solid called a net to find the surface area of the solid. Surface area is measured in square units. Now we've already learned about area back in chapter 4, but now we're going to find the surface area of a 3D figure. So you already know the formulas for rectangles, squares, and triangles, and those are the basic three shapes that we're going to be using with surface area. So surface area of a 3D figure is like wrapping up the box, but not overlapping corners or anything like that. It's literally like this color coding. Pretend this is a tissue box and you're going to put a piece of blue paper on the two sides. You're going to put a piece of green paper on the front and the back, and then a piece of pink paper on the top and the bottom. So you're cutting out the paper to exactly fit all sides, all faces of this object. So in order to find the surface area, you just find the area of each face. Now in a rectangular prism, there's going to be duplicates. Like this front is going to look exactly like the back, and you can kind of see that here with these two green pieces. The top and the bottom are going to be the exact same size, and the two sides are going to be the exact same size. So when you kind of unfold this and flatten it out, then you can find the area of these 6 pieces and then add them together. So in last week's notes, I sent you an attachment, and hopefully you were able to print out. This is I think the first page in that handout that I had attached last week. Now don't worry about these formulas. These formulas you may eventually use, but in 6th grade, just starting off finding surface area, I'm going to show you more a more visual way to find the surface area. Excuse me. So here are some basic shapes. In today's lesson, we're just going to be going over a rectangular prism or a cube. That'd be very similar. And then a triangular prism. So it doesn't have to be a right triangular prism. This just means this is a right angle. So here would be the nets for those shapes. So if we were to cut them apart and open them up, these are the nets. And you can kind of see how many faces we're actually looking for. Next week's, or I think the next lesson is going to get into pyramids, so that will be at the bottom of this handout. So for right now, we're just focusing on the first 3 pictures. Also in that handout, you had these figures. Well, I just printed it, cut it out, so that you could see the net. If I were, these are just the little tabs that you can glue. If you glued them all together last week, if you can print off another copy. That way you can open them up. But clearly, if you close this, this is just a rectangular prism. But by not gluing it, I can open it up and kind of see all of the faces. So here you can see that I labeled this the back, because that would fold up to the back. The bottom, this would be the front, and this would be the top if I enclosed it. And then these 2 would be the sides. So that's what they're doing here, as well as this example. And then, oh, here we go. Hopefully that'll stop in a moment. Okay, there we go. Has a little glare, but hopefully you can still see through this. Okay, so they have this box. Now they have dimensions on it. These are all in inches. So they unfolded the box, and then they put those labels where those dimensions would be, and then they found the area of each individual face. Here are those areas. And then to find the surface area, all you do is add up all those numbers, and they got 122 square inches. All units are in squared units. We can do the same thing for a triangular prism. Here on that original handout, here's another triangular prism. If I cut it apart and unfold it, these are going to be the faces. So there's going to be 5 faces. You can see the 2 triangles will be identical, but these 3 rectangles are all different. So that's going to be the difference between prisms and rectangular prisms. So here they have that rectangular prism. They unfolded it. You can see all the sides. They labeled everything. They color-coded everything. And you can see that these are 3 different colors, showing that these are 3 different sizes. Even though this blue and red looks pretty similar, but they are going to be different. Here is just another triangular prism. They unfolded it here. They found the area of all 5 faces. They color-coded everything, and then they just added everything up. So you can pause this, you can take your time and go through these pictures, make sure those dimensions are making sense to you. But I'm just going to go ahead and do a couple of these examples right at the bottom. Here is that right triangular prism that you have in the handout. You can cut apart and kind of get some ideas on the prisms. That's what these examples are doing. And here are my notes. So, surface area of prisms. Remember, a net, that's one of our vocab words. It's a 2D representation of a solid, and that's all these are. It's just a 2D, 2-dimensional. They're flat. You can lay them out. You unfold and flatten whatever figure it is. And then I have in here, see the handout sent out in last week's lesson. So in number 1 at the bottom, here, I just kind of recreated that rectangular prism. I unfolded it so you could see what it would look like. Now all I got to do is find the area of each one of these faces. So here's my shortcuts. F is for the front and the back. Now remember, the front and the back are going to be the same size. So whatever I get for one, I'm going to get for the other one. My 2 sides are also going to be identical. And then my top and my bottom will also be identical. So if you look at the front, that's this. And I'm going to kind of show you on here because you don't always want to cut apart and break everything open. So the front would be this shaded area. Now what are the 2 numbers that go with this rectangle? Because remember, rectangle is the length times width. So that would be the 9 and the 5. This 6 is this side, so we don't need that 6. So it would be 9 times 5. And the front and the back are going to be identical. So that's where we get 45 for each one of those. Now I'm just going to erase so you can see my shading in for the other parts. Let's do the sides. That would be this over here. Well, I know this bottom is 6, but what is this side? Well, if this side is 5, that also means this side is 5. Because remember, opposite sides of a rectangle are congruent, are equal. So the side would be 6 times 5. And both of them are going to be the same. That gives me 30 for each. Now the top or the bottom, I'm just going to shade in this bottom part so you can see what 2 numbers give me the bottom. Length times width. That would be this 6 and this 9. So 6 times 9 is 63. And then it is not 63. What am I thinking? 6 times 9 is 54. Okay, so now I know y'all have calculators, so feel free to get a calculator out, and then all you have to do is add up all these sides. I'm just going to put my plus sign over here. So that would be 45 plus 45 plus 30 plus 30 plus 54 plus 54. 258 would be my answer. And it is in meters, remember labels, squared. So 258 meters squared would be the surface area of this rectangular prism. Now there's a circle method that works for rectangular prisms only. So anything that looks like a box, you can use this circle method. And this is a lot easier. So what you do is you just kind of go around in a circle. So start at any given point. So 6 times 9. That's 54. And you're going to do it twice. And now you're going to go 9 times 5, and you're going to do that twice. And then you're going to go 5 times 6, and you're going to do that twice. And then if you notice, since it's the same box, it's the same dimensions as this one, all of my numbers should be exactly the same as what we did here. They may be in a different order, but that's okay. So if I have 2 54s, 2 54s, 2 numbers that are 45, 2 45s, 2 30s, 2 30s. So if I were to add this up, I would also get 258 meters squared. So same answer, just a different method. And I really like the circle method for any type of rectangular prisms. Because again, you're just going around in the circle, but remember, you got to do everything twice. I'll show you another. Circle method for number 2, this tissue box. We can have fractions, we can even have decimals. You would do the same method. So you can either unfold it, kind of shade in and get all your each face, or use the circle method. This is a boxy looking figure, so why not use the circle method? So again, start at any given point, 5 times 5, and we're going to do that twice. And then 5 times 6.5. Well, I'm gonna want to use a calculator, so I'm just gonna turn 6.5 into a 6.5. That way I can plug it right into my calculator. And then I gotta go to 6.5 all the way around to this 5. And now answer all these. 5 times 5, that's an easy one. 5 times 6.5. Let's just use our calculator. 32.5. And this is basically the same thing, except we just flip-flopped our numbers, used the commutative property. So this is also going to be 32.5, 32.5. Now all we have to do is add up all those numbers. 25 plus 25 plus 32.5 plus 32.5 plus 32.5 plus 32.5. And what do we get? 180. And this time we're still talking about inches. Inches squared. And that would be your answer. So feel free to use the circle method or just unfolding it and using the net for any type of rectangular prism. Now number 4, I'm going to do 4 and 5 as well. Number 4 is not a rectangular prism, so we cannot use the circle method. That's a real bummer because that's a nice method to use. So here I have this triangular prism. I unfolded it, and this is what it looks like. And again, you have one of those if you printed out your handout from last week that you can use to help you. So now I have everything labeled. I have a side and a side, a bottom. I don't have a top because remember it's just this line on the top, but I do have a front and a back. So here I use my shortcut symbols, and now I gotta just figure out the areas of each face. So I'm going to do my front and back, and my front and back are the only two faces that are exactly the same. These three are all different. So if I look at my triangle for my front, I'm just going to shade that in, and we have a 3 and a 4. But if you remember the formula for a triangle, area of a triangle equals 1/2 base times height. And so I have to take half of 3 times 4. And remember, we can easily take half of 4, which is a 2. 3 times 2 is 6. And the back is going to be the same size. Now I can look at the bottom. Well, my bottom is 3 times 4. This 5 has nothing to do with the bottom, and this 3 has nothing to do with the bottom. So by shading in each little section, that's going to make it easier. So 4 times 4 is your bottom, which is 16. Now the sides are a little bit trickier to find. I'm going to do this side. Kind of looks like it's in the back, but I'm going to call it a side because when I unfold it, it's over here. So what numbers? This is a rectangle, so it's just length times width. I know it's a 3, but what's this bottom? Well, the opposite side is 4, so that means this side down here has to be 4. So that gives me a 3 times 4, which is 12. Now the other side is kind of tricky to see, but it's this big side right here. Think of this as like a ramp. So this shaded side is a 4 times 5. It's a rectangle, so it's just length times width. 4 times 5, that gives me 20. And then feel free to use your calculator. 6 plus 6 plus 12 plus 20 is 44. This time we're talking about yards, and they're squared. Alrighty, I got one more example for you. And again, I'm not even going to unfold it because I know this is a triangular prism. It's going to look very similar to this. So I'm just going to go ahead and make my front and back. I always put back because I don't get it confused, so I don't get it confused with the bottom. And my front and back are going to be the same. Then I'm going to have a bottom, and then I'm going to have a side and another side, and then I'm going to add up all those answers. So the front and the back. Now this triangle is not a right angle, so I have to remember area of a triangle is 1/2 base times height. So I have a 16, I have a 10, but then I have this 6 pointing to this red line. Remember, when we find the area of a triangle, you're looking for that perfect L with that right angle. So right here, those are the two numbers that we need to see. This 10 is extra information for the triangle. I don't need that. So my 1/2 base would be 16, and my height is going to be this 6. And your back is going to be the exact same triangle. So 1/2 of 16 is 8. 8 times 6 is 48, so that's going to be the same. Now let's look at the bottom. This bottom is a rectangle, so it's just going to be length times width. Hopefully you're able to see that is 16 times 9. And I'll use my calculator in a minute for that. Now, let's do this side. Again, if it looks like a ramp, like we're going to skateboard up this ramp. We have a length and a width, 9 times 10. That's 90. And now this side over here. Well, I know this side is 10. What's this bottom? Well, if this side is 9, that means that side has to be 9 as well. So this time our two sides happen to be the same size, and that sometimes happens. Now I can just first finish off 16 times 9, 144. Clear, and I'm just going to add up all of my numbers. So 48 plus 48 plus 144 plus 90 plus 90. 420. This time we're talking about meters squared. Alrighty, kind of a longer lesson. Not hard. It's just more time consuming because you're finding the area of lots of different sides. So that's it for lesson 8.2. You can head over to bigideas.com and you have an assignment there, 10 problems. Actually, I don't even know if there's 10 full problems. I think I gave you a few less since there's so many steps involved in each problem. So best of luck to you guys. Have a great day. Miss you all.